Okay, so today we'll be continuing with functions. All right, and we had looked at an example where we were given f of x equal to 2x squared minus 3x plus 1, and we were asked to find certain values for f of x, where f of x was f of minus 3, f of 0, and f of 2. But in functions, you may not necessarily use the letter f. You could use another letter. So you could use a letter like G, for example, and they could tell you G of x is equal to 3x minus 1. All right, that's another way to write a function. This letter here, it doesn't have to be f. It could be g, it could be h, it could be k. It doesn't matter. It just says that you're going to do something to x. In this case, you will take x multiplied by 3 and minus 1. Another way of writing this here, another way of writing that is like this. G such that x maps onto 3x minus 1. Okay, so you could write g of x in this way as well. So if you go in the exam and you see them write it like that, you know it means the same thing. Okay? So in this instance, I want you guys now to work out for me what g of 2 is in part 1, and in part 2, I want you guys to work out now for me what g of minus 3 is. Okay, so work on that now, please. Right in class here, do that. Try it and let me see what you get. The next example is if h of x is equal to x squared minus 1, if h of x is equal to x squared minus 1, for what values of x is h of x equal to 8? Okay? If h of x is equal to x squared minus 1, for what values of x is h of x equal to 8? So basically, if h of x is equal to x squared minus 1, find values of x when h of x is equal to 8. That's what we need to do. Okay, now I realized that the mic was off when I was talking about this one, so I'll just talk back about it so that whoever is watching the recording will know how to do it, right? And just to quickly go over this here, we had to find g of 2, and it meant that we took 2 and replaced x by the 2. So it became 3 multiplied by 2 minus 1. 3 multiplied by 2 minus 1. And that became 3 by 2 is 6 minus 1, worked out to be 5. And when we had to do g of minus 3, what we did is we took the minus 3 and substituted it for x. So we got 3 multiplied by minus 3 now, minus 1, which was minus 9 minus 1, which worked out to be minus 10. Okay? That's because the recording didn't have the audio when I was doing it, so I just did it for the benefit. So we come down to h of x equal to x squared minus 1. Find the values of x when h of x equal to 8. Okay, so it's a simple one in that all we have to do is find out when x squared minus 1 is equal to 8. Right? That's all we have to do. Find out when x squared minus 1 is equal to 8. Because h of x is x squared minus 1, and we want to know the values of x when h of x is equal to 8. So it means we want to solve the equation x squared minus 1 equal to 8. Okay? And once we could solve that, we don't have any problem. Now one way to do that is to say x squared is equal to 8 plus 1. Add 1 on both sides. So we get x squared is equal to 9. And therefore x is equal to the square root of 9. So what should we put there? What should we put here? What's the square root of 9? Right, the square root is not plus 3. Always remember it's plus or minus. Right, that's why I asked you about 3 times. Because I want you to always remember it's plus or minus 3. When you put it on the calculator will only give you plus 3. So you have to remember the other one, minus 3. Otherwise you wouldn't get the full marks for it. Okay? So just take a note on that. Okay, the next question we will do is a very important one, right? So we'll pay a little more emphasis on it as we look at it now. So you'll write it down. If k of x is equal to 3x plus 5 over 2x minus 1. If k of x is 3x plus 5 over 2x minus 1, state the real value of x which cannot be in the domain of k of x. Now this question is very important because it's a question that can come in the exam and a number of people wouldn't know how to start, right? And you, once you understand it, you'll be able to get full marks in questions of this type. And it could be a favorite, okay? Now, before we actually answer that, there's a concept that you have to learn and understand. And the first question I'm going to ask you is, I would like you guys to tell me, what is 1 divided by 0? What is 1 divided by 0? Anybody? 0. 0. 1 divided by 0. 0. Anybody says anything else other than 0? Okay. So what I want you to know that if you guys, as everybody here said, was 0, the answer is wrong. Right? That is a wrong answer. So I want you to understand that you need now to type it in your calculator and verify what I just said to you. Type in for me now on your calculator, what is 1 divided by 0? And see what your calculator tells you. Right? What is it? Error. And error is not the same as 0, right? Right. It means that something is wrong. It means that when you put that in, your calculator tells you error. Most people think 1 divided by 0 is 0. But it is not. 1 divided by 0 is an error. It's actually undefined. It's actually meaningless. Right? So whenever we have 1 divided by 0, or as a matter of fact, any number or term right, or expression divided by 0, you get the same exact situation. Okay? So I want you to be aware of that. However, what is 0 divided by 1? What is 0 divided by 1? You sure? Put it on the calculator and see now. What are you getting? 0. Right. So the same thing holds now. 0 over any number always gives you back 0. Okay? So 0 over, I'll just put anything to summarize it. Anything. Whether it be a number, a term, or expression, 0 over any one of those will still give you 0. Now, having appreciated this, right, we can now come back to what we have to do here, right? Because you needed to understand this before we could actually explain and understand the solution to this question. Okay, so the question again says, if k of x is 3x plus 5 all over 2x minus 1, state the real value of x which cannot be in the domain of k of x. And I want you to learn these words here by heart, so that when you see it in the exam, it will ring a bell immediately and you'll know exactly what to do. Now, if we want to state the real value of x which cannot be in the domain of k of x, I'm going to write a statement here for you. I'm going to write this: 2x minus 1 cannot be equal to 0. Do you all agree with that? Because if 2x minus 1 was 0, we would have something divided by 0. And we learned that something divided by 0 is an error, is undefined, is meaningless. Not so? That's what we just learned. So therefore, when this is 0, this statement is undefined. It's an error, it's meaningless. So what we are saying is 2x minus 1 could not be equal to 0. Because if it is, everything becomes meaningless. Okay? So we write that 2x minus 1 cannot be equal to 0, and therefore 2x cannot be equal to 1. Right? Because if 2x was 1, 1 minus 1 will give you 0. So 2x cannot be equal to 1, and therefore x cannot be equal to a half. Okay? X cannot be equal to a half. Therefore, we could write x equal to a half is the real value of x which cannot be in the domain of k of x. Because if x was a half and you place it here, this whole thing will become meaningless. It'll be nonsense. Okay? If x was a half, let's say this, and you put a half here, right? 2 by a half would be 1. 1 minus 1 will be 0. And we learned that anything over 0 is meaningless. So it means that x cannot be equal to a half. It's that it is therefore the real value of x which cannot be in the domain. It cannot exist. You cannot consider it to be part of this relationship, because if it were, it would cause everything to be an error and meaningless. So the solution lies by saying, hence, this is how you write it down, hence, x equal to a half is the real value of x which cannot be in the domain of k of x. Okay, so that's what you write. So write it. Now the word domain that they're talking about here, in the domain means all the possible values that x could take. So they say state the real value of x which cannot be a member of the set of all the possible values that x could take. And we know x cannot be a member of all those possible values, because if it were, it would cause the whole function to be meaningless. Okay, so that's what that is about. Okay, so we're looking at composite functions now. And you write, given f of x equal to ax plus b. You can write as I write. And g of x equal to cx plus d where a, b, c, and d are constants. Constants meaning numbers, actual numbers. And x is a variable. Variable meaning that it will, in the equation, x will remain as x, but a, b, c, and d will be numbers, like 1, 2, 3, 4, 5. Given that we have those two functions, f of x and g of x, then if we have to find the composite function, let's say we have to find the composite function f g of x, if we have to find the composite function f g of x, it will be equal to a open bracket c x plus d plus b. It'll be equal to a open bracket cx plus d plus b. We obtain this function. F g of x by substituting g of x for x in f of x. We obtain this function, which is fg of x, by substituting g of x for x in f of x. In general, you may not have the function fg of x, right? You may have different functions. You may start off with h of x and k of x. So in general, we have a way of expressing it. What we say is, in the function on the left, wherever we see x, we substitute or replace it with the function on the right. So this is the general form of what the equations could look like, the functions could look like. And whereas this is a specific example, this here tells you exactly what you do regardless of what the functions are. So if we were to revisit this expression here, what we say is, in the function on the left, which is f of x, so we go and we look at f of x here. We look at it. In this function on the left, which is f of x, wherever we see x, which means we are seeing x in that position there, we will take it out and we will replace it by the function on the right, which means you replace it by g of x. So we'll take out x, and instead of x, we'll put in what g of x is. G of x is cx plus d. So this will be a, and instead of x, we'll put cx plus d plus b, which is what we have here. A, cx plus d plus b. Okay? So what we'll do now is we'll look at some specific examples. Okay, so the first example we look at is, given we have the function f such that x maps onto 3x minus 1, and we have the function g such that x maps onto 2x plus 5, we need to find or determine, the first thing they want us to find is fg of x. The second thing they want us to find is fg of minus 3. The third thing they want us to find is g f of x. And the fourth thing they want us to find is gf of minus 3. Okay, so we have to find all these different things. So the first one we look at, of course, is f g of x. Okay, that's the first thing we're going to look at. Finding that composite function, f g of x. Now, in order to find f g of x, we revisit what we learned. What we learned is that in the function on the left, wherever we see x, we will replace it with the function on the right. So in the function on the left, which is f, let's write down that. Function f of x is 3x minus 1. The function on the left, which is f of x, which is 3x minus 1, what we'll do is we'll take out this x and we will replace that x by the function on the right. The function on the right is g of x, so we will replace that x by 2x plus 5. So 2x plus 5 will come into that position instead of the x. So really and truly, this should be written as 3, open brackets, 2x plus 5 minus 1. Okay? In the function on the left, which is 3x minus 1, we substitute or replace the x, wherever we see that x, by the function on the right. Function on the right was 2x plus 5. So all we did was we took that and we replaced the x with it, and we ended up with 3 into 2x plus 5 minus 1. Remember, when you do substitution, you must use brackets. So the next step here, of course, would be to say, expand it. So the 3 is multiplied by the 2x, 3 is multiplied by the 5. So you get 3 by 2x, 6x, plus 3 by 5, 15, minus 1. So this becomes 6x plus 15 minus 1 is plus 14. So what we could write, therefore, is that f g of x is equal to 6x plus 14. 6x plus 14. What I want you to be aware of is that in the exam, this area here is not really supposed to be shown. This is what you are supposed to be doing mentally. So that if you want to write this down in scrap somewhere and then come and write this part here, from here go down, then that is what is required of you. You are required to say the things in your mind and come up with from here, then here, then here. Okay, but this here was just a way for you to see how to actually execute it. If we are required to find in part 2 f g of minus 3, that will be found by saying in f g of x, what we will do is replace the x by the minus 3. In f g of x, instead of using the x, we'll use minus 3. So it becomes 6 by minus 3 plus 14, and that works out to be 6 by minus 3 is minus 18 plus 14, and minus 18 plus 14 works out to be minus 4. So what we can say is that fg of minus 3 is equal to minus 4. Fg of minus 3 is equal to minus 4. try for me now gf of x. Try it on your own and see what you come up with. Gf of x, see what you come up with. Okay, so in part 3, where we had to find gf of x, what we say is in the function on the left, which is g of x, which is 2x plus 5, 2x plus 5, what we are saying is that instead of x there, we will replace x by the function on the right, which means we will replace the x in 2x plus 5 by f of x. And f of x is 3x minus 1. So in 2x plus 5, we will replace x by 3x minus 1. So we write 2, open brackets, instead of x, we'll place 3x minus 1, close brackets, and then add 5. So gf of x means in the function on the left, which is 2x plus 5, replace the x with the function on the right, which is 3x minus 1. And we end up with what is on the board now. So that will be equal to 2 multiplied by 3x, 2 multiplied by minus 1 plus 5. 2 by 3x is 6x. 2 by minus 1 is minus 2 plus 5. So this will work out to be 6x plus 3. Okay, 6x plus 3. Okay, and part 4 required us to find gf of minus 3. So if we have to find gf of minus 3, all we have to do is replace the x in gf of x by minus 3. So we will replace the x in 6x plus 3 by minus 3. So we get 6 by minus 3 plus 3. 6 by minus 3 plus 3, which works out to be minus 18 plus 3, which works out to be minus 15. Okay? All right. So that is, if they guided us through that method, we would go through that method. But there's something else that we need to be aware of, which we'll do now. Okay, so we take note that in the first method we use, we got fg of minus 3 equal to minus 4. And we got gf of minus 3 equal to minus 15. Now there's an alternate method, another method we could use to do this. And in that alternate method, we would not have had to find fg of x first and then find fg of minus 3. If they had just told us find fg of minus 3, we didn't have to go through that process. There's another way we could do it. And the method that we could use is to first of all work out what g of minus 3 is, and then take that answer and substitute it into f of x. fg of minus 3 is the same thing as working out what g of minus 3 is and taking that answer and placing it into f of x. You will get the same answer you got previously when you used the other method. Let's try it and see. Let's work out g of minus 3 first. G of minus 3 means take minus 3 and replace x here in g of x. So it will become 2 by minus 3 plus 5 minus 6 plus 5, which is equal to minus 1. That's what g of minus 3 is. So fg of minus 3 could now be written as f of what did we get for g of minus 3? We got minus 1. So instead of writing back g of minus 3 here, I'll put minus 1 in its place. So I'll have to find f of minus 1. And if I find f of minus 1, I'll be able to say that that will be f g of minus 3. So let me find what f of minus 1 is. F of minus 1 will be, going back to what f of x is 3x minus 1. So f of minus 1 will mean remove the x and replace it with minus 1. So it becomes 3 by minus 1 minus 1. And that works out to be 3 by minus 1 is minus 3 minus 1. And minus 3 minus 1 is equal to minus 4. So therefore, fg of minus 3 is equal to minus 4. And we did find that that was the case when we did it the first way. So we know that this method is also correct. Okay, we'll do it on the other one as well. Let's say we had to find g f of minus 3. Let's say we had to find gf of minus 3. So if we had to do a similar method to find gf of minus 3, what we would do first is to find f of minus 3, and whatever that answer is, we'll then take it and find g of that answer, right? So let us find, first of all, f of minus 3. F of minus 3 would be equal to, we go back to what f of x was, it was 3x minus 1, and we'll substitute minus 3 for x in f of x. That is, we'll substitute minus 3 into 3x minus 1. So it becomes 3 by minus 3 minus 1, and that'll be equal to minus 9 minus 1, which is equal to minus 10. We get minus 10. So therefore, what we are saying is, if we want to find g f of minus 3, and we already know that f of minus 3 is equal to minus 10, all we'll do is take that minus 10 and replace f of minus 3 by it. So this becomes g of, instead of f of minus 3, we'll put minus 10. So we get g of minus 10 instead. G of minus 10 will be, take minus 10 and replace it by x, and replace x with it in g of x, which is 2x plus 5. So in 2x plus 5, we replace the x by minus 10. So you get 2 by minus 10 plus 5. So therefore, gf of minus 3 is equal to 2 into minus 10 plus 5, which would be equal to minus 20 plus 5. And minus 20 plus 5 is minus 15. So therefore, we could say that gf of minus 3 is equal to minus 15. And minus 15 is what we got for it up here. So we know that what we did is absolutely correct. There's also a point to note here that the functions themselves, these composite functions, are non-commutative. It means that if we reverse them, you don't get the same answer. In other words, fg of minus 3 is not the same thing as gf of minus 3. Fg of minus 3 is minus 4, and gf of minus 3 is minus 15. So if you reverse them, you do not get the same result. Whereas in multiplication, plain multiplication, for example, if you replace the order, you get the same result. Here, you do not. So we could write a small note to ourselves. We could say that the note is fg of x is not the same thing necessarily as gf of x. In other words, composite functions are not commutative. They are not commutative, meaning you cannot reverse them and get the same result. Oh shit. Okay? So you take note that fg of x is not equal to gf of x. It means that composite functions are not commutative. You cannot change around the order and get the same result as in the case of simple multiplication. Here, if you change it around, you get different answers. Since fg of x is minus 4 and gf of x is minus 15. Okay, so we look at a more elaborate one where we'll be using like negative numbers and fractions in the examples. So let's say we were looking at f of x equal to x minus 3 over 2x plus 1. We're looking at g of x equal to 3x plus 1 over minus 1. And also h of x is equal to 5x plus 3 all over x minus 2. Okay, you have those three functions. And the first question they asked was, evaluate f of a half. Then they asked us to find also in part 1 h of minus 2, evaluate f of a half and h of minus 2. And then the second part, part B, was show that gh of minus 2 is equal to 25 over 3. Show that gh of minus 2 is equal to 25 over 3. So if you have to evaluate f of a half, it means that wherever we see x in f of x, we replace it by a half. So f of a half will be equal to a half minus 3 over 2 by a half plus 1. All we did was, instead of x, we placed the half instead. Okay? Now, if we work this out, a half minus 3, a half minus 3 is minus 2.5. 2 by a half is 1. 1 plus 1 is 2. And if we take minus 2.5 and divide it by 2, you'll get minus 1.25. Minus 2.5 divided by 2, we'll get minus 1.25. So it means then that f of a half is equal to minus 1.25. So that would be one answer here. That would be one answer for A. But we also had to find out what h of minus 2 is. We have to work out what h of minus 2 is. So to get what h of minus 2 is, all we'll do is say h of minus 2 will be equal to, we'll place minus 2 for x here and here. So it becomes 5 by minus 2 plus 3 over minus 2 minus 2. All we did was we replaced the x with minus 2. So what happens is that this becomes 5 by minus 2 is minus 10. Minus 10 plus 3 is minus 7 on top. And below we'll get minus 2 minus 2, which is minus 4. So we'll get minus 7 over minus 4, which is the same thing as saying 7 over 4, right? Because when you divide top and bottom, same sign, the result is going to be positive. So this is 7 over 4, or if we want, we could bring it down to a mixed number. 4 ones are 4, 5, 6, 7, so you have 1.75. So we have h of minus 2 is 1.75. Any questions so far? Good? Okay. So the next thing we're going to work out is part B here, where we have to show that gh of minus 2 is equal to 25 over 3. That's what we're going to do next. So we work that here. We have to show that gh of minus 2 is equal to 25 over 3. Now gh of minus 2 means that we have to work out h of minus 2 first. And when we get that value, we will take it and substitute it in g of x. That's what we'll have to do. Now, as I mentioned to you before, what you would have learned is that in some of these questions, as you go along further and further, you are required to have the knowledge that sometimes they will ask you to use information from before. So when I see this, I start to use that knowledge and I say h of minus 2. Wait now, I think we did that before. So let's look back. We did it here. So we know h of minus 2 is 7 over 4 or 1.75. I will use that here because gh of minus 2 will be the same thing as g of whatever h of minus 2 worked out to be. And we know h of minus 2 worked out to be 7 over 4 or 1.75. So I'll just use the 7 over 4 in this example. So gh of minus 2 is g of 7 over 4. And what we'll do now is we'll substitute 7 over 4 in g of x, which is here. So what it becomes 3 multiplied by 7 over 4 plus 1 all over 7 over 4 minus 1. Okay? That is going to become. Now we are required to show that it's 25 over 3. So how do we proceed with that? Well, let's see. 3 by 7 over 4. 3 by 7 is 21. Right? 3 by 7 here is 21 over 4 on top. Plus 1. That 1 could be written as 1 over 1. This one here could be written as 1 over 1. And the bottom part here is still 7 over 4. So we write that minus 1. And that minus 1 could be written as minus 1 over 1 as well. If we are to work this out, have to continue. Let's see what happens next. If we find the LCM of the top part, the 4 and the 1, that'll be 4. So I'll put that LCM of this 4 and this 1 here will be 4. And we say 4 into 4 is 1. 1 by 21 is 21. 1 into 4 is 4. 4 by 1 is 4. So the top part could be written as 21 plus 4 over 4 using normal fractions. And the bottom part could be written as, if we take the 4 and the 1 and we get the LCM again, that'll be 4 once again. And we say 4 into 4, 1. 1 by 7 is 7. Minus 1 into 4, 4. 4 by 1 is 4. So what I did is I took the top and expressed it as we would if we were adding fractions normally. And I took the bottom and did the same thing. So what we would end up with next is we could then write GH of minus 2 would be equal to, if we work out the top part here, we'll get 21 plus 4, which is 25 over 4. We get that on top, over what we'd get at the bottom, 7 minus 4. When we work out this part at the bottom here, we get 7 minus 4 is 3 over 4 at the bottom. Like this. So 25 over 4 over 3 over 4, or 25 over 4 divided by 3/4 could be written like this. If I take out that over sign and I write 25 over 4, instead I write this sign, I'll write divided by, because it means divided by 3/4. Like this. What happens then? Division is the same thing as multiplying by the inverse. So instead of 3 over 4, we'll put 4 over 3. And then what we'll observe is that this 4 will cancel with this 4. And then when we simplify, 25 by 1 on top will give us 25. And 1 by 3 below will give us 3. So in that way, we would have proven that GH of minus 2 is equal to 25 over 3. And once you do a proof, you use that sign at the end of the solution as I put in here, which means I've proven what you asked me to do, and therefore I deserve all the marks for it. Right? I've proven that GH of minus 2 is 25 over 3. Now, anytime they ask you to do a proof, it is required that you show them the working to come to the answer. Right? If you could shorten it, you know, like say if you could add up all of this on top with your calculator and come up with 25 over 4, and do all this below and come up with 3 over 4, at least you would then be able to flip it here and show them the result. But for those who may not have had a calculator, or those who wanted to see the working right through, this is the way that you could do it to show them the proof. Okay, so the next thing we look at is finding composite functions where we have 3 functions involved, not just 2. Okay? In part 1, they ask us to find f, g, h of x. The procedure there is to take 2 functions at a time, starting from the right. So what you do is you would group these 2 functions and work them out. And then, having found that, then you will combine it with that function last. So you do not go this way, you go this way, from right to left. So what we will find first is what GH of x is. And when we get that, we will combine that with f. So how do we find GH of x? We use the same method. In the function on the left, which is g of x, wherever we see x, we will put or substitute the function on the right. So in g of x up here, where we have x plus 2, we will remove the x and we will place h of x in its place. So instead of x, we will place 3x plus 1 instead of x. And then we will add 2 to it. So in the function on the left, which is x plus 2, wherever we see x, we will replace it with the function on the right. So instead of x, I wrote 3x plus 1 plus 2. This will work out to be 3x plus 1 plus 2 is the same thing as 3x plus 3. So that is what GH of x is. But that's not what we are required to find. We are required to find f GH of x. That's what we require to find. But gh of x is 3x plus 3. So another way of writing this is saying f of 3x plus 3. And what that means is, in f of x, in this one, which is here, wherever we see x, which would be at this point, we will remove that and we replace it with 3x plus 3. So what that will come down to be will be 2, and instead of x we will write 3x plus 3, and then we'll do the minus 1, which will be minus 1. gh of x we found to be 3x plus 3, but we need to find fgh of x. So what we'll do is we'll find f of, instead of g of x, we'll write down, instead of gh of x, sorry, we'll write down 3x plus 3, which is what we found gh of x to be, and we will find f of that. So in f, wherever we see x, we replaced it with 3x plus 3, and we got this expression here. This works out to be 2 by 3x, 2 by 3. 2 by 3x is 6x, 2 by 3 is 6, minus 1. So this works out to be 6x plus 5. 6x plus 5. So we could say then that fgh of x is equal to 6x plus 5. That would be the answer for part 1. We do part 2 next. So if we have to now find in part 2 fgh of 2, all we'll do is we'll write in fgh of 2 will be equal to, and instead of x in fgh of x, that is, instead of this x here, we replace that with 2. So we get 6 by 2 plus 5, which will work out to be 12 plus 5, which in turn will work out to be 17. So your answer, therefore, is fgh of 2 is equal to 17. So this will be your answer for that second part. fgh of 2 is 17. Okay, so the next heading is inverse of a function, and I'd like you to take down this. The inverse of a function, is that function that takes a y value. The inverse of a function is that function that takes a y value obtained from the original function and maps it back to the x value, and maps it back to the x value that it came from, and maps it back to the x value that it came from. Full stop. To determine the inverse function, we follow this procedure. Step 1. Write the defining equation for the function. Step 1, write the defining equation for the function. i.e., step 1 is write the defining equation for the function. Write the defining equation for the function. i.e., that is, let y equal to the function. i.e., that is, let y equal to the function. Step 2, interchange x and y. Step 2, interchange x and y. Step 1 was write the defining equation for the function. Write the defining equation for the function, i.e., let y equal to the function. i.e., that is, let y equal to the function. That was step 1. Step 2 is interchange x and y. Step 2, interchange x and y. Step 3, make y the subject of the equation. Step 3, make y the subject of the equation. That's step 3, make y the subject of the equation. Step 4, state the inverse of the function. Step 4, state the inverse of the function. Now, a very easy way to appreciate inverse is to consider this relationship. Let's say we had an initial function y equal to 2x. Another way of writing y equal to 2x is to write it like this. F of x is equal to 2x. That's another way to write that. Okay? So, in your method, we said if f of x equal to 2x, the first step was to state the defining equation, or simply put, let y equal to the function. So let y equal to 2x. Okay? They mean the same thing. But if I wanted to find out what x is, I'd have to say y over 2 would be equal to x. In other words, this is what I would have to do to get back the original value of x that y came from in the first place. If we use numbers to illustrate it, if I said 20 is equal to 2x, and I wanted to find out what x was that gave me 20, what would I have to do? Divide 20 by 2. So the inverse function is 20 divided by 2. Or y divided by 2, because that function gives me back the value of x that 20 came from, not so? Just divided by 2. Now, and that means that the function, the value that 20 came from was 10, not so? What about if I wrote 70 was equal to 2x? How would I find what x is? Divide 70 by 2 again, and that will give me x equal to 35. Good? So again, 35 is the value of x that 70 came from. And the inverse function is not 2x. The inverse function is y divided by 2. Or whatever the value is divided by 2. So the inverse function is that function that gives me back the value of x that the y value came from. Okay? But in all instances, it's not as simple as this to see. That's why you have a procedure in front of you. And if you follow that procedure, you will be able to do any inverse function. So let us look at a couple examples. And let's say we're looking at example 1 here, where they say if f of x is equal to 4x minus 3, find the inverse of the function. Find the inverse of the function. That was step. That was A. And then B now. If g of x now, g of x is equal to 5x minus 1, calculate the values of, or find g of 2. Next step, g of minus 1 equal to 0. And then the next part, g to the minus 1 of 2. Okay, let's say we have to do these things. So, to do A, which is to find the inverse function for f of x, what it is we have to find actually is called f to the minus 1 of x. That is how you write the inverse function. Okay? So the inverse function of f of x is f to the minus 1 of x. And what do we normally do is, the first step, if you read your steps there, is to state the defining equation or defining function. So you write the defining equation for f of x is, and you write y equal to whatever the function is. In this case, it's 4x minus 3. If you're in a rush, you could say let y equal to 4x minus 3. Right? But this is the perfect way to do it. The defining equation for f of x is y equal to 4x minus 3. The next step is to interchange x and y. That's the second step. So it means then, the next step is interchange x and y. That means wherever I see y, I'll write x. Wherever I see x, I'll write y. Okay? That's the second step. I interchange x and y. The third step is to make y the subject of the formula or subject of the equation, which means get y on one side and everything else on the other side. So this from here, I could say that 4y minus 3 is equal to x. If x is equal to 4y minus 3, then 4y minus 3 is equal to x. And then from here, I could start to solve for y, which means get y on one side and everything else on the other. So it means I could write now 4y is equal to x plus 3. Right? And then I could also write that y would be equal to x plus 3 all over 4. Now that actually is the defining equation for the inverse function. So you write, this is the defining equation for the inverse function. Right, that is the defining equation for the inverse function. Therefore, you could write the inverse function, which is f to the minus 1 of x, as being equal to x plus 3 over 4. Those are the steps that you have in your book. Right? Those are the steps that I gave you. Okay? So the first step is to write that the defining equation for f of x is this, or let y equal to the function. The second step was interchange x and y, which we did. The third step is to make y the subject of the formula, which we did. Recognize that when we reach that point, it is the defining equation for the inverse function. So the inverse function is actually what is on the right, which is x plus 3 over 4. In the second example, we were told that g of x equal to 5x minus 1. And the first thing we wanted to do was calculate the value of g of 2. So to get the value of g of 2, all we do is place 2 for x in g of x. So this will be 5 by 2 minus 1, which will be equal to 10 minus 1, which is equal to 9. So g of 2 is equal to 9. So that's one answer. That will actually be the answer for part 1. For part 2, we will ask to find g to the minus 1 of 0. But to find g to the minus 1 of 0, we have to find g to the minus 1 of x, which is the inverse function, first, and then substitute 0 into it. So we need to find g to the minus 1 of x, and of course, you write the normal thing, the defining equation for g of x is, and you let y equal to that, y equal to 5x minus 1. Okay? That's the first step. The next step we do is we have to do the interchanging part. So we interchange x and y. So what happens when you interchange x and y? You get x is equal to 5y minus 1. The third step is to make y the subject of the formula. So from here we would get 5y minus 1 equal to x. And we could manipulate this formula, so we get 5y is equal to x plus 1, and therefore y is equal to x plus 1 over 5. That actually is the defining equation for the inverse function. So this is the defining equation for g to the minus 1 of x, or the inverse function. Therefore, g to the minus 1 of x is equal to x plus 1 over 5. But having gotten that, then you could work out the second part. Because the second part asks us to find out what g to the minus 1, or the inverse of 0. What is the value of g to the minus 1 of 0? So it means now we put 0 into that equation, so you get 0 plus 1 over 5, which works out to be 1 over 5, or 1/5. And they also want you to find g to the minus 1 of 2, which is very easy in part 3. If they want you to find g to the minus 1 of 2, that's not a problem. G to the minus 1 of 2 means take 2 and substitute it in g to the minus 1 of x. So you get 2 plus 1 over 5, and that would work out to be 3 over 5, or 3/5. So g to the minus 1 of 2 is 3/5. is equal to 3y plus 2 multiplied by 1. So if we multiply by 1, we get back 3y plus 2. The next step is to expand. So we get x multiplied by 2y would give us 2xy when we do this multiplication here. And then x multiplied by minus 5 on this side will give us minus 5x. So we get 2xy minus 5x on the left hand side is equal to 3y plus 2. The next step is to get all the y's on one side and all the x's on the other side. Any term that contains y, we will get it on the left hand side, and any term that doesn't have y in it, we'll get it on the right hand side. So what happens is that 2xy minus 3y will be equal to 5x plus 2. I did two things there. I minus 3y on both the right hand side and the left hand side. So that took away the 3y from the right hand side, and it created a minus 3y on the left hand side. In addition to that, I removed the minus 5x from the left hand side by adding 5x, so that came out, and I also added 5x on the right hand side. Because remember, whatever I do on the left hand side, I must also do it on the right hand side. The next step was take out y as a factor. So I'll get y here, 2x minus 3. If you take out y as a factor, and I get 5x plus 2. The next step is to realize that if I divide the left hand side by 2x minus 3, I'll get y. So I'm going to divide the left hand side by 2x minus 3, I'll get y. And I'm going to have to divide the right hand side by 2x minus 3 as well. So it'll come down to be 5x plus 2 over 2x minus 3. And once we reach that point, that is the defining equation for the inverse function. So we could write, therefore, the inverse function, which in this case would be f to the minus 1 of x, will be given by that relation, 5x plus 2 over 2x minus 3. 2x minus 3. Okay, so we are looking at solution of an equation using the inverse of a function. You're right, below that. The inverse of a function, the inverse of a function can be used to solve an equation. The inverse of a function can be used to solve an equation. Full stop. The example is very important. To right after that, to solve the equation, find the inverse function. To solve the equation, find the inverse function and substitute what the original function was, and substitute what the value of the original function was. The value of what the original function was, that is 7 in this case. That is 7 in this case. That is 7 in this case, into the inverse function. Into the inverse function. So this question here is one of the most challenging that you would see. It involves finding the inverse and using it to solve an equation and then stating the real value of x, which cannot be in the domain of f of x, which we spoke about before. So to find the inverse of that function, what do? We say let y equal to 3x plus 2 over x minus 2, if you recall. And then we interchange x and y, so x over 1 would be equal to 3y plus 2 over y minus 2. That was the second step, you interchange. Then the third step in this case would be to cross multiply. So if we cross multiply x by y minus 2, and then 3y plus 2 by 1, we'll get x multiplied by y minus 2 is equal to 3y plus 2, because we did cross multiplication like this. X by y minus 2, and then 3y plus 2 by 1, and put them equal. The next step is to multiply inside, so we get x by y, xy. X by minus 2 is minus 2x is equal to 3y plus 2. The next step there is to make y the subject of the equation. And to do that, we get all the y terms on the left-hand side. And we get all the terms without y on the right-hand side. And we get xy minus 3y is equal to 2x plus 2. Then we take out y as a common factor, so we get y into x minus 3 is equal to 2x plus 2. And then we divide both sides by x minus 3, so we get y is equal to 2x plus 2 over x minus 3. And once we do that, we could say that this is the inverse function. So the inverse function, in this case, of f of x, which is f to the minus 1 of x, would be equal to 2x plus 2 all over x minus 3. But the reason that we are getting the inverse function is to solve this. So if we get the inverse function of the original function, to solve it, what your note said was to take the value that the original function was, which in this case is 7, and substitute it into the inverse function. When we do that, the answer will give us the solution of x that we're looking for. So all we do now is find the inverse function of 7. So f to the minus 1 of 7 will give us the solution that we're looking for. So f to the minus 1 of 7 means take 7 and place it in here. So it becomes 2 by 7 plus 2 all over 7 minus 3. Okay, and that works out to be 14 plus 2 over 10, which is 16 over 10. Sorry, 7 minus 3 is 4. Sorry, something was looking strange. 7 minus 3 is 4, so 16 over 4, right, which becomes 4. So what we're saying is the solution of 3x plus 2 over x minus 2 equal to 7 is 4. Right? So you write, hence, the solution that we're looking for is x equal to 4. And if that is true, you could check it back, take x equal to 4 and place it there and see if you get 7. If what we did is correct, then if I place x in this equation, I should get 7. So if you put x equal to 4 in 3x plus 2 over x minus 2, Let's see what happens. 3 by 4 is 12 plus 2 is 14. You get 14 on top. And 4 minus 2 below is 2. So 14 divided by 2 is 7. So we know that this is the correct solution. It works out when you substitute it. All that was part A. And part B now, state the real value of x which cannot be in the domain of f of x. All we do is we appreciate that x minus 2 cannot be equal to 0. So if f of x is equal to 3x plus 2 over x minus 2, then we know that the bottom part cannot be equal to 0, otherwise it would be meaningless. So you write x minus 2 cannot be equal to 0, which means that x cannot be equal to 2. Hence, x equal to 2 is the real value of x which cannot be in the domain of f of x. Okay? So and that will solve that one.